All right, so I think this is recording. Let's take a look at problem number 1. We're given a polynomial function of fifth degree. We look to see if there's any greatest common factor, and there's not. So we look to see if there's any missing powers on any of the exponents. 5, 4, 3, 2, 1, 0. There's not. We look at the factors of the constant term as possible numerators in a list that we're going to generate, and this list will be the possible rational zeros for this function. So the factors of the -1 are just 1 and -1, and the leading coefficient is also 1. So our possible list then is just plus or minus 1. So let's look to see if 1 gives us a 0. So we've got 1, -1, 2, -2, 1, -1. So with that alternating pattern, I'll bet that it will. And yeah, it does. Okay, so with such a high degree and only 2 possibilities, I would think that there could be a really strong chance that this has a multiplicity that's greater than 1. But let's see if it is. That's yet to be determined. So it's not. So I would have guessed that this would have been 0 there, but it's not. So let's try -1. And it's not either. So we're at the end of the list. All right, so let's write it in factored form and see if anything comes to mind. So this function, instead of writing it in standard form like it's given, we can write it as x minus 1. That fifth degree, this guy is now fourth degree, so that 1 is 1x to the fourth. There is no x cubed, and then 2x squared. And there is no x, and then plus 1. So this is a trinomial that's quadratic in form. So let's, even though that's not, even though it's not quadratic, it's quadratic in form. So we can apply the x method and see if we can factor this. So the first term times the last term is 1x to the fourth, and 2 numbers that when multiplied together give us the top of the x, but when added give us the bottom of the x, or 1x squared and 1x squared. So if I set this equal to 0, this factors to x squared plus 1 times x squared plus 1. And we can write that in factor form as x squared plus 1 quantity squared. Now x squared plus 1, we can't factor that any further. So if these 2 numbers, when multiplied together, well, with the squared, the 3 factors, when multiplied together give us a 0, it has to be because x is equal to 1. The x squared plus 1 will never equal 0 because x squared within the set of real numbers will never be -1. So we've got two values here, two positive numbers that are being multiplied together, and that's not going to result in a 0. So our final answer for number 1 is just a 0 of 1. These other 4 zeros would be complex numbers. All right, so I'm going to keep going in the same video. And number 2, do we have a greatest common factor? Yeah, and x is definitely common everywhere. So let's factor it. And now I've got 9x to the 4th minus 42 x to the 3rd plus 61x squared minus 28x plus 4. So we now focus our attention on this 4th degree polynomial. And again, I don't see any common factor to that. So I'm going to look at the, I'm going to use the rational zero theorem. I look to this constant term, and I look at the factors of 4, which are just 1, 2, and 4. And I look to the leading coefficient, which is factors of 9. And now, remember the factors of the constant term are going to be numbers that we put in a numerator, and the factors of the leading coefficient are numbers that we're going to put in a denominator. We're going to create this list that is possible zeros, rational zeros. We say possible because there may not be any. So let's go through and take each of these numbers, 1, 2, and 4, as numerator and divide it by 1. So when we divide by 1, we just get these values back again. When we take each one of these and divide it by 3, we get this. And when we take each one of these values and divide it by 9, so we've got a kind of a long list to check to see if any of these will produce a 0 for this function. So this was number 2. Well, let's just jump in and see if we can't find a 0. I'm going to do synthetic division rather than plugging it in. So 4, 3, 2, 1, 6. No, nothing's missing. So let's see if we get a 1 here. Don't think we will. I don't trust myself, even with simple arithmetic. 28. And we don't get a 4. We don't get a 0. Oh, I'm tired. I'm sorry. So let's try -1. Doesn't look like it's going to work either, does it? Yeah, this is definitely not heading towards 0. All right, so we've tried both 1 and -1. Let's go ahead and try 2. -61 minus 48. 13. Now this is starting to look promising here, isn't it? There we go. We found a 0. All right. So, well, this was a 4th degree. So now this is a 3rd degree. Well, we just have to keep looking in this list. We don't know for certain what's going to happen here. All right, so let's try 2 to see if there's a repeated root. Nope. I'm starting to think, wait a minute. Yeah. 9, 18, -6. Okay, there we go. So we've got a repeated root. So now we've got it down to a quadratic. All right. So you'd think since I was the one that created these, and I would remember what I did and not be so excited, but I didn't remember. So this has multiplicity 2. And now this guy is 9x squared minus 6x plus 1. So we can do our x method on it. But you might be able to see that it's 3x minus 1 times 3x minus 1. Because or 3x minus 1 quantity squared, the negative times negative is positive, and that gives you a -3x and another -3x, which is -6. So let's say, though, that you didn't see that. Let's do our traditional x method the way that you're pretty comfortable with. This minus 6x here, first term times the last term, is 9x squared. So 2 values that when multiplied together give you the top expression, but when added give you the bottom. Since the leading coefficient is not 1, go ahead and construct a table. And in the body of the table, along one diagonal, put the first term and the last term. And along the other diagonal, put the values you found in your x. Now, since this diagonal is both negative and that's a positive 1 right there, this is going to be -1 and -1. And this has to be 3x and 3x. So, let's see if I can't shrink that down a little bit. Or at least move it out of the way. Well, I've got a different color, but that really doesn't matter, does it? X minus 2 squared, and 3x minus 1 squared. So that's going to produce the zeros of x equals 0, x equal 2, with a multiplicity of 2, and x equals 1/3, because if you add 1 and divide by 3, that also has a multiplicity of 2. So with 2 plus 2